Hello, everyone.
我是
I'm ZHAO Chuang. Today, let's meet Maya the Tameryraptor, a large carcharodontosaurid dinosaur. This creature was about 10 meters long. Although its fossil remains are limited, they include some key parts, such as a large portion of the skull and the legs. The discovery and study of this dinosaur involved many twists, and it wasn't given the name Tameryraptor until this year. This name honors its fossil site, which is now in Egypt. Tamari comes from the ancient Egyptian name for the country, meaning beloved land. In Chinese, it is sometimes translated as G2Dao Loom, beloved land raptor, or IG Dao Loom, Egypt raptor. However, we still use the transliteration of Tamari, somewhat reminiscent of how China was historically called Huaxia or Jindan. Although this dinosaur was only recently named, its fossils were discovered early on. As far back as in 1914, at the beginning of the last century, fossils of this species have been found. At the time, research on ancient creatures was less advanced. Many carnivorous dinosaurs were often easily identified as Megalosaurus. Because its tooth shape resembled that of Megalosaurus, it was named Megalosaurus saharicus. Over the years, more fossil specimens were also excavated. Unfortunately, those fossils, along with the then famous specimens of Spinosaurus and some Carcharodontosaurus remains, were destroyed during World War II. Later, after Carcharodontosaurus was named, researchers analyzed the surviving photographs and realized that the described Megalosaurus saharicus might actually belong to Carcharodontosaurus. As a result, these materials were reclassified under Carcharodontosaurus. This year, researchers re-examined the fossil photographs and observed some differences. The partial skull and leg remains still exhibit features that are distinct from those of Carcharodontosaurus. So, it is now recognized as a new genus called Tameryraptor. First, let's look at this animal as a whole. Its body length could reach 10 meters, making it a very large carnivorous dinosaur. Then, we examine this model part by part. The key skull remains include the nasals and the maxilla, which hold the upper teeth. When we reconstructed this Carcharodontosaurid, we used a lip restoration. So, when it closes its mouth, its lips cover its teeth, and when opening, the upper teeth are mostly hidden. From a top-down view, you can see these parts of the teeth. One notable feature that sets it apart from Carcharodontosaurus is this small nasal horn. Carcharodontosaurus also had a nasal horn. In fact, all Carcharodontosaurids, along with many other carnivorous dinosaurs, generally had keratin-sheathed protuberances on top of their snouts. In Carcharodontosaurus and related species, this part was relatively flat, whereas that of Tameryraptor was large, prominent, and horn-like. This is the most distinctive, recognizable feature that distinguishes it from Carcharodontosaurus. The entire shape of its head resembled that of Carcharodontosaurus, featuring two lacrimal crests above the eyes, which have fused with the thick brow bones to form large horns. In our previous reconstructions, these were sometimes depicted as separate structures. In this model, we used an exaggerated restoration, making them fused into a single, horn-like formation. Like Carcharodontosaurus, its posterior temporal fenestrae were quite large. Although its fossils didn't include this part, the skull shape suggests its head likely had a similar structure. It had a typical pointed Carcharodontosaurid snout, with its lower jaw closely resembling that of Carcharodontosaurus. It had numerous teeth in its snout, unlike Giganotosaurus, which only had teeth at the front. As a Carcharodontosaurid, Tameryraptor probably had teeth extending farther back. Living around 90 to 100 million years ago, the temporal and geographic range of Tameryraptor likely overlapped with Spinosaurus or Carcharodontosaurus. This indicates that Africa was home to a diverse array of carnivorous dinosaurs during that time. Moving backward, let's look at its neck. Like Carcharodontosaurus, it had a very thick neck, a trait shared by all group members. Notably, the back of its head might have arched high, which is an important feature of Carcharodontosaurids. Carnivorous dinosaurs usually had low neural spines on the dorsal side of the cervical vertebrae, but Carcharodontosaurids featured the opposite. They always had tall, large neural spines on their necks, resembling a row of shark fin-like structures. These neural spines protruded and were tightly arranged, like tiles, covered in muscles to create a sturdy yet flexible structure, another characteristic of Carcharodontosaurids. Additionally, Carcharodontosaurids had tall neural spines along their bodies, with dorsal spines generally taller than those of dinosaurs, like Allosaurus or Tyrannosaurus. Their bodies were robust, and from above, their rib cages appeared very solid. Next, let's talk about an interesting feature of Tameryraptor, that is, its legs were very long. Based on the body proportions of typical Carcharodontosaurids, the legs should be much shorter, roughly this long. You can picture a Carcharodontosaurus or Giganotosaurus in your mind. They generally had sturdy bodies with shorter legs. However, this was not the case for Tameryraptor. Therefore, we reconstructed this model with its body being slightly upright to highlight this feature. The long legs suggest this dinosaur might have been good at running, and likely occupied a different ecological niche from Carcharodontosaurus or the short-legged Spinosaurus. They probably had different habits. Furthermore, regarding its forelimbs, no forelimb fossils have been discovered, but we can speculate that this dinosaur likely resembled most Carcharodontosaurids with shortened forelimbs. Moving to its hindquarters, let's look at its thick tail. From the midline of its dorsal spine to this point on the tail, the position of the transverse processes is roughly here. The left and right transverse processes of the caudal vertebrae, the two wing-shaped, plate-like bones, were probably located at this position. These two bones form a row that divides the muscles into upper and lower groups, with the dividing line here. The tail of this dinosaur was quite sturdy, possibly serving as a counterbalance during running or walking. Since the fossils lack foot bones, we reconstructed the feet based on typical Carcharodontosaurid feet. In this model, you can see a pair of typical theropod feet. It had a short toe and 3 relatively long, functional toes. All toes had nails of similar size, unlike Taurovenator or Meraxis. It might have lacked the large second toenails. Good. The above concludes our introduction to Tameryraptor. Thanks for watching.